Okay. Yeah. Before we're going a little bit like further to do the tuning, I have some updates about the performance of Relion 3D classification benchmark result. You see here is we are using the Relion 3.1 and one AC92 with 4 V100 GPU. If we are not tuning anything, it's about like 60 minutes on the system to run to finish. But if we do some like tuning, including the software tuning, and we are linking with the performance library, and the best time we can get is like about 32.6 minutes. Is around like 33 minutes. So if we compare to the the x86, right we showed before, there'll be like almost like 2.5 times faster than x86 with the same V100 GPUs. So this is the latest update we can get for Relion performance. And I want to start to show some of the user guide. Yeah, basically, this chart is like everything is based on the similar cluster at MIT. Like they have 64 nodes of AC92 cluster, and I think all the setup is pretty similar. So I can using this one to show how we can do the optimization and use the cryo-EM software package. So like the whole package, including the Relion and cryo-YOLO and CTF5 and Motion Core 2 and ResMap. It is all the software are able to do, and some of the modules actually replace the Relion module to run better on the AC92 nodes. So we can have like the motion correction to all the modeling. Everything is ready in the package. And also I have also enabled the eMan2. It's a similar package, like it's a complete package, like to run all the cryo-EM workloads. And if you prefer to using eMan2, you can also using eMan2. It's also available there for you to enable. Just activate it. So the individual part is not like it's not in the one here. I set up is in the project. Like I think the BDDIR04 folder, and that just using the module low IBM collaboration, and you can then activate it. And I don't know if anyone like prefer to using a containerized package. If you prefer that, I can make the container available for you. So you just like need to pull the container, and you have all the package like similar to the Anaconda. Okay. So because everything is running with the Slurm scheduler. So once you activate your cryo-EM environment, you can start to using the sallocates to allocate your nodes. Once you got the node through, you can run Relion with indirectly, or just like running everything in background. So some people, some professor, they like to run the GUI interface. So in this case, you can using S1 to start your interface, GUI interface, and run that. yeah, if you want to run in the background as a batch job, you just like to do this using the similar example script here. And here, I think I did like receive some feedback about the parameters we are setting. Yeah, someone recommends like some of the parameter like the fast subset and the maxic parameter. These two is give you some better performance, but may not like, yeah, is getting your like the good results you want. But if you have a lot of data you want to process, I think this two parameter is good for you to set to run faster. It means the people tend to be curious about their results. So that means they want to start running the whole thing faster to get the result. If they seeing the good one, they tend to run the regular job. So that is because is why the people in MIT, they recommend these two parameters to the people, but may not getting the best result. But for us, like in terms of performance, we like to have the performance, like getting better performance is our goal. That's why we recommend these two parameters here. So any question about the parameter setting here? Okay, another thing is like we on our system we have 160 threads. So that means the combination of the number of threads, the dash n and the dash j, the combination is pretty tricky. It means like if you get the good combination, you can get a better result. In this case, like 17 times 10 is supposed to 170. Actually, it's not. Like because rely on using one master thread to do all the coordination. So that means actually the number of thread you're running is 16 times 10 is 160. And you may getting like when you're running, because running so many threads, you may see some of the errors say out of memory, because like sometimes the people share like I don't know if you're set when you're running your batch job, maybe you have to setting in the dedicated mode. If you're not setting, maybe someone are still running their jobs on the system when your jobs being allocated. So that means multiple jobs running on the same system and cause the out of memory. And also some of the common errors like loading the share library is not available. In this case, you have to make sure your library is assist, and also your library path is linked to the actual share library. And some of the error like is very rare is the bus error. This maybe is not, it means like it's the software built on other system is not compatible on your system. So in this case, like just let me know. I think probably some of the module, especially the Python, when you are activated, sometimes is they are installed the x86 module for you, especially when you're using the PIP to do the installation. And when you're running the MPI job, some of the parameter you like, especially the bind to the CPU binding or thread binding, you have to set to none for the Relion job, because we have the combination of thread and cores to put together. If you set to something like core or thread, they're running all the jobs into a certain subset of the cores that cause the performance issue. Yeah, this is an example. We can start the Relion with the GUI interface and start the pipeline from the motion correction to up to all the modeling, getting the results. Yeah, one of the similar the small example here is I did is I getting the image from beginning, and finally I do the refinement and getting a better image. Yeah, I think that is it for me. And the performance tuning is, the trick is like we have to remember two things. First, we have the difference is like we have the number of thread per physical core is 2. So on the AC922 system, is the system scheduler is pretty much optimized to running multiple thread at once. So that is a big difference, like from x86. Even x86 has like also has 2 virtual thread per core, but their system scheduler is not like optimized for better use. So most people find like if you're using 2 thread per core, you can cause a performance degradation. But it's not the case for power. The power is getting better. Like one example is when we're using the BWA to application to align the genomic sequence, if you're using like 40 cores versus 160 core, 40 threads versus 160 threads, we can get about 3.5 times faster. Even like the physical core is the same, but we are running 160 threads, we can get 3.5 times faster. And another thing is like Intel has the MKL library. We have in IBM we have the ESS. I think that is the one for me.